Not $300, not every 2 years, $4, one tube. That is the entire equation, and the fact that you have never heard it spoken plainly, never seen it printed on a dealer invoice, never had a service advisor slide it across the counter alongside your brake estimate. That silence is not an accident. It is architecture, deliberate, profitable, and 50 years in the making. The squeal of rotors biting into worn pads, the acrid smell of burnt brake dust baking off a rotor you were told needed replacing, the grit of metallic powder on your fingertips when you finally pulled the wheel yourself and found a caliper pin seized so hard it had been grinding one side of your pad into nothing for 30,000 miles. That is not mechanical failure. That is a service model, a business decision dressed up as physics. And the worst part is not that it costs you $300 every 2 years. The worst part is that the fix costs $4, takes 4 minutes, and has been documented, proven, and quietly used by professional mechanics on 2 continents since before most of the cars on the road today were designed. The industry knew this. The engineers knew this. The fleet managers running hundreds of commercial vehicles on razor-thin maintenance budgets knew this better than anyone. And the dealership service bay that quoted you $340 last spring knew it too, in the way that a magician knows exactly where the coin went. They just needed you looking somewhere else. To understand why your dealership never told you this, you have to go back to Japan, 1971, where the trick was born inside the very industry that would spend the next 50 years pretending it did not exist. Toyota and Nissan were running commercial taxi fleets at a scale that made maintenance cost a survival question, not a preference. These were not small operations. These were hundreds of vehicles running daily in dense urban environments, accumulating mileage at rates that exposed every weakness in standard Western maintenance protocols within months instead of years. Fleet engineers in those programs, working under sustained pressure to extend vehicle life across large numbers of units simultaneously, began documenting something that the Western repair market would later call irrelevant and quietly exclude from every consumer-facing service document it ever produced: the systematic lubrication of caliper slide pins and pad backing plates using high-temperature copper-based anti-seize compound, applied at every single brake service, not occasionally, not as a repair step after something went wrong, every time. Proactively, as a standard line item in the maintenance protocol, costing the equivalent of $2 to $4 American per application and adding exactly 4 minutes to the service time. The results documented in internal fleet maintenance logs were not marginal improvements. Brake component service intervals pushed far beyond factory expectations, in some documented fleet cases reaching 80,000 to 100,000 miles per set, while comparable Western vehicles on identical driving profiles were cycling through brake jobs every 30,000 to 40,000 miles like clockwork. The compound cost almost nothing. The application was simple enough for any technician to perform in the time it takes to wipe down a dipstick. And here is twist 1, the irony that makes the entire story snap into focus and stay there. This protocol was discovered, documented, and proven inside the commercial vehicle programs of the very manufacturers whose dealer networks would later profit enormously from selling you the brake jobs the protocol was specifically designed to eliminate. The solution was not hidden in a classified research facility. It was not locked behind a patent wall. It was sitting in a fleet maintenance log in Osaka, in a trade publication that circulated among Japanese automotive engineers, in the institutional memory of mechanics who had watched the numbers play out across tens of thousands of vehicles over multiple decades, while Detroit was printing parts catalogs and training service advisors to upsell rotors. While Japanese fleet managers were measuring the distance between service intervals in numbers that seemed impossible by Western standards, American dealerships were building the franchise service model that would define automotive retail for the next 40 years. And that model had one structural requirement: your brakes needed to wear on schedule. The franchise service model that expanded aggressively across the United States through the 1980s was not built on mechanical complexity. It was built on mechanical ignorance, specifically on the customer's ignorance of the single cheapest intervention that changes every number on a brake service estimate. A service advisor at any franchise dealership in 1985 would quote you pads, rotors, hardware, and labor without once mentioning the $4 tube sitting on a shelf 30 feet away that could double the life of everything he was about to sell you. The service manual did not mention it. The training curriculum did not include it. The parts catalog certainly did not recommend it. Nobody banned the trick. They just made sure you never needed to know it. The National Automobile Dealers Association's own service revenue data from that era tells the story in dollars. Brake service services ranked among the highest volume recurring upsells in the dealership service bay, a reliable revenue line built on intervals that had no technical reason to be as short as they were, on vehicles driven by people who had no framework to question why their brakes wore out on the same schedule as their oil changes, the brake parts aftermarket itself, a global supply chain generating billions of dollars annually by the 1990s, had zero financial interest in longevity compounds reaching mainstream consumer awareness. A tube that costs $4 and extends pad life by a factor of 2 or 3 represents near zero revenue for the supply chain. Replacement pads, replacement rotors, replacement hardware, and the labor to install all of it on a predictable interval represents an entire business model built on the presumption that the cheap preventive step does not exist. The enemy was never a single executive sitting in a boardroom deciding to suppress Japanese fleet data. It was a structure, a recursive loop of replacement revenue that required your brakes to wear on schedule, and that schedule was only sustainable if the $4 variable stayed permanently invisible to the people paying the bills. The enemy wasn't a person, it was a business model. Now look at the engineering, because this is where the suppression becomes almost insulting. Automotive tribologists, engineers who study friction, wear, and lubrication at the material science level, have documented the primary failure mode of disc brake systems in language that never appears in any consumer-facing service brochure, dealership estimate sheet, or manufacturer owner's manual. Caliper slide pins are the mechanical guides that allow the caliper body to float laterally across the bracket and apply even clamping pressure across both brake pad surfaces simultaneously. When those pins corrode and seize, which they do predictably and reliably under the combined mechanical stress of heat cycling, road moisture, and the total absence of lubrication that standard service protocols create, the caliper stops floating. One pad drags continuously against the rotor surface. One pad wears in weeks what should take years. The rotor absorbs uneven heat across its face and begins to warp. The pedal develops a pulse. The squeal starts. The service advisor hears it, writes the estimate, and hands it across the counter like a tax you forgot you owed. The compound, copper slip rated to 1,100 degrees Celsius, ceramic brake paste rated to 900 degrees, applied correctly to those slide pins at every service interval, prevents seizure entirely. It is not a repair product, it is a maintenance step that eliminates the primary mechanical cause of the failure that generates the repair bill. Engineering studies and fleet data confirmed that the majority of premature brake wear traces not to pad material quality, not to rotor metallurgy, not to driving style, but to seized slide pins causing chronic uneven pad contact pressure. The science existed in technical literature for decades. The industry just hoped you would never read it, and they were right about most people, until independent mechanics started talking. Independent mechanics who began adopting the Japanese fleet protocol through the 2000s reported results that aligned precisely with the original fleet data. Slide pins free moving and fully functional at 70,000 miles, where they had previously seized solid at 30,000, even pad wear patterns replacing the dramatic single-side grind that forces rotor replacement, near total elimination of brake squeal complaints from customers, and service intervals that stretched in ways the dealership model had never budgeted for. Shops that adopted the protocol discovered something structurally important about their own business. Their brake service revenue dropped because their customers' brakes stopped failing on the schedule the industry had always depended on. Independent shops that know this trick have customers who never come back for brake work ahead of schedule. That is the entire point. And then twist 2 arrives, and the $300 service estimate dissolves under basic arithmetic. The physical materials in a complete brake job. Pads at $30 to $60, depending on vehicle and grade. Rotors at $40 to $80 per axle. Hardware kit at $5. Compound at $4. Total somewhere between $80 and $150 at retail price. Purchased by you directly, with no labor markup attached. A dealer estimate for the identical job runs $280 to $340 at minimum, climbing past $400 on European and luxury vehicles. A margin of $150 to $200 built entirely on labor for a job that the $4 compound, applied correctly at the previous service, could have pushed back by a full service cycle. Consider the lifetime arithmetic that the industry never prints on any document it hands you. Without the protocol applied, 8 brake services over 240,000 vehicle miles at $300 per service equals $2,400 spent across the usable life of one vehicle. With the compound applied correctly and consistently at every service, documented fleet data and independent mechanics mechanic records converge on 4 to 5 service intervals over the same total mileage at a realistic DIY cost of $150 per service, producing a lifetime total of $600 to $750. The difference between those two numbers is $1,650 to $1,800 per vehicle. One tube, one lifetime. $1,800 back in your pocket, compounding across every vehicle you will ever own. Modern commercial fleets running the full lubrication protocol, taxi operators, rideshare maintenance depots, last-mile delivery vehicle programs carry maintenance logs showing brake service intervals extended from the standard 30,000-mile replacement cycle to documented ranges of 60,000 to 80,000 miles per service under real-world operating conditions that are harder on brakes than anything most private drivers experience. The protocol used in those fleet garages is not proprietary chemistry. The compounds are not special order industrial products requiring a fleet account to purchase. They are sitting on the shelf at every AutoZone, O'Reilly, and Napa location in the country, priced at $4, labeled clearly, and purchased by almost no one who is not already a working mechanic. Taxi fleets in Osaka cracked this 50 years ago. You are just hearing it now. Here is the complete protocol, the identical procedure used by Japanese fleet mechanics since the early 1970s, stripped of every complication the industry added to make brake service feel too technical for a private owner to touch. Buy one tube of copper anti-seize compound or ceramic brake lubricant, Permatex, CRC, Worth, any reputable brand, 20 grams, approximately $4 at any auto parts retailer. When you have the wheel removed and the caliper unbolted from its bracket, take a wire brush and clean all visible corrosion from the caliper slide pins before you touch anything else. Apply a thin, even coat of compound to the full length of each slide pin before sliding it back through the caliper body. Next, take a clean rag, confirm the friction surface of the brake pad is completely clean, then apply a pea-sized amount of compound to the bare metal backing plate on the non-friction side of each pad. The flat steel back, not the material that contacts the rotor under any circumstances. Apply a thin smear of the same compound to the caliper bracket abutment clips and the contact ears of the pad where metal meets metal under braking load. That is the complete procedure. 4 application points per corner, pea-sized amounts at each point, no excess, no contact with friction surfaces or rotors. 4 minutes per axle. Repeat at every brake service without exception for the remaining life of the vehicle. This is twist 3, and it reframes every brake service estimate you have ever received. The compound that changes all the numbers has been on a shelf at your local auto parts store for the entire time you have been paying $300 for brake jobs. It was never hidden in a vault. It was hidden in plain sight on a shelf right next to the parts they needed you to keep buying. The proof supporting this protocol is not anecdotal and not thin. Copperslip's verified thermal rating of 1,100 degrees Celsius sits well above the 300 to 700 degree operating range of brake rotors under normal street and highway driving, confirming the compound does not break down between services, does not migrate onto friction surfaces when applied in correct quantities, and does not degrade in ways that require reapplication before the next scheduled service. Engineering literature on caliper pin lubrication documents the failure mechanism the compound prevents. Fleet maintenance records across multiple decades and multiple countries document the interval extension the compound produces. Independent mechanics who logged before and after results across their own client vehicles document the wear pattern improvements the compound delivers consistently. 3 independent source categories, 5 decades of operating data, 1 result that never changes. Engineers knew, fleets knew, mechanics knew, now you know. The $300 brake service was never a technical inevitability written into the physics of disc brakes. It was a revenue line, carefully maintained, built on the deliberate absence of a 4-minute maintenance step that the industry removed from its own training materials and left off its own specification sheets, because the mathematics of its presence destroyed the mathematics of its absence entirely. You are standing in your garage now, the wheel pulled, the caliper resting on the rotor hat, the faint metallic smell of brake dust hanging in the cold air, the same copper compound that a Japanese fleet technician was pressing onto taxicab slide pins in Osaka 50 years ago, sitting on your workbench in a tube that cost you $4. They built a billion-dollar service empire on the one thing they hoped you would never buy. You just bought it.